Azure provides a variety of operating system images that you can install onto the virtual machine. This includes several versions of Windows and flavors of Linux. That also means you can have both client and server-based operating systems. The choice of your operating system will eventually influence your hourly compute pricing as Azure bundles the cost of operating system license into the price. So if you're looking for more than just operating system images, you can search the Azure Marketplace for more sophisticated install images that include the operating system as well as popular software tools installed for specific scenarios. For example, if you need a new WordPress site, the standard technology stack would consist of a Linux server, Apache web server, a MySQL database, and PHP. So instead of setting up and configuring each component, you can leverage Marketplace image and install the entire stack all at once. Finally, if you cannot find a suitable image, you can create your own disk image with what you need, upload it to Azure storage, and use that storage to create an Azure virtual machine. Now keep in mind that Azure only supports 64-bit operating systems. In the next video, we'll learn about what Microsoft Azure does not support. Let's assume that you are running a Windows 2012 R2 operating system in Azure. And because of certain business requirements, you would like to do an in-place upgrade of the operating system. That means that you want to run 2016 or 2019 instead of 2012 R2 on the same VM. As on today, Microsoft does not support an upgrade of Windows operating systems of a Microsoft Azure virtual machine. Then what is the solution? Well, you should create a new Azure virtual machine with the operating system that you want. In this case, it's going to be either 2016 or 2019. And then you do a migration of your data from Windows 2012 R2. So your workloads on 2012 needs to be migrated to 2016.
Azure Compute Service. Now, Azure Compute is an on-demand computing service for running cloud-based applications. It provides computing resources such as disks, both SSDs and regular HDDs, processors of different kinds, memory of different configurations, networking, and operating systems. The resources are available on demand, and that can typically be made available in minutes or even seconds. You pay only for the resources you use and only for as long as you're using them. Now, you will use these resources such as processors or memory for creating virtual machines and containers. In the next set of videos, you will learn what virtual machines are and how do you create them using the Azure portal. In this video, we'll learn how do you create a virtual machine using the Azure portal. At this time, I'm logged into the Azure portal with my subscription, which is there. You can see on the top right hand side, keeplearningcloud@hotmail.com is my user ID that I've used, and the subscription is pay as you go. When you want to do a similar lab like this, you may need to have your own subscription. You can create your own free subscription, and I'm going to show that to you in the subsequent videos. At this time, let's just learn how to create a virtual machine. Now on the left hand side, you see list of Azure services that it provides as on today. And we want to create a virtual machine, so I will click on the virtual machine section and then click on create virtual machine. You can either click on this blue button or click on this plus icon. That's the same thing. Now what it's going to open now is a wizard that will show us a couple of options that we need to fill up. For example, selecting the subscription, the resource group, virtual machine, etc. So we have to follow this wizard. Microsoft is known to make things easy by giving us a wizard way of installing something, a wizard method of provisioning something. In this case, it's a virtual machine. The first thing that we have to do is select subscription. So if you create your account for the first time, this will not be pay as you go. This will be a free tier account. I will be creating a new resource group. In one of the videos earlier, we learned about what a resource group is. Resource group is a collection of resources so that you can later on charge the business unit back, or maybe apply certain policies, do certain troubleshooting on that resource group. In the previous example, we said that the resource group name is human resources, so you can apply policies and then bill charge back the HR business unit. In this case, I'm going to create a new resource group because I do not have one. So let's name the new resource group as payroll and say okay. Now, what's your name of the virtual machine? Always follow certain standards for creating a virtual machine, and you may have to ask the business unit what their standards are. Now, let's name the virtual machine as VM Web 01. There are certain naming standards that Azure itself has. If you look on the right hand side, it says that the resource name cannot contain special characters. Virtual machine name must be unique in the current resource group. The value is in between 1 to 64 character long, and all characters are valid for Linux OS. Looks like I'm compliant. So moving next. Do you remember the picture that I was showing about the world map where we had the Azure data centers? Now, as you see here in this picture, the Azure data centers are available everywhere. That's what the next option is about. Where do you want to create this virtual machine? Now, all those blue dots that you saw on the map is what these lists mean. So you can select one of these geographical regions. So the best practice is to choose a virtual machine that is closest to the user. Right? So let's go ahead and select East US. In this case, I have this habit of selecting East US. Availability options, remember what availability options were. So if you want to make sure that your virtual machine does not get impacted by any natural disasters, man-made issues, or could be patching, updating the firmware on the machine, things like that, so you may want to choose an availability option to make sure that it's available at all times. But in this case, it's just a test environment, so I'll leave the availability option at this time. The next option is image. What kind of operating system are you looking for? Do you want a Windows, or are you looking for a SUSE, CentOS, Red Hat? You got all of these options. I'm going to select a 2012 R2 data center. The next option is how much of compute power, the size that you want to give to this machine. You got different permutations and combinations. So I'm going to click on change size. Then you will see different combinations available. So this one is D4SV3, which is giving me 4 CPUs and 16 gigs of memory. Although you can choose anything, but I will stick to this, which is giving me 1 CPU and 3.5 gigs of memory. So that's fair enough. I don't need more than that for the lab. Administrator account. Make sure that you choose, or rather say, do not choose a regular name like administrator or root, because Microsoft does not accept it. Let's give it a shot. Administrator. So say usernames must not include reserved words. Even usernames like root are not accepted because these are reserved words. So I'm going to choose root admin. Okay. The password, make sure that it is complex and fits the compliance rules as well. So yeah, password is matching. Make sure that it's long enough, it's complex, it has special characters, uppercase, lowercase, to make sure that the unethical people out there on the internet do not guess it so quickly with their tools. Now, this virtual machine is being created somewhere out on the internet, somewhere in Azure, in one of the data centers, which we selected East US right here. So this is a Windows-based virtual machines, and I must be allowing certain inbound ports for us to access it from my network in this case. So I want to allow port number 3389 so that I can RDP to this machine. What's the point of creating a virtual machine in Azure if I cannot access it? So if I want to access it, I need two things. One is an inbound connection allowed on RDP because it's a Windows machine. If I would have selected a Linux machine, I would select SSH. Yeah. Now I also have the username and password. So once this machine is ready, I'm ready to RDP. RDP is remote desktop protocol, which will let us connect to the machine over remote networks. Okay. So in the next section, we can select the disks. How much of hard disk size do you want, and whether you want a premium SSD, a standard SSD, or a standard SSD. The differences between these will be IOPS, or input output per second, or the performance that will be directly related to these options. Premium SSD is used for mission critical workloads that are production sensitive. Now, because this is just a test environment, I'm going to choose standard HDD. Other option here is to create and attach a new disk. So this one is just going to create a C drive, but I can have multiple disks attached to it, which will be D, E, and F drives subsequently. Clicking on next, it gives me the option to select the virtual network. Now, every time you see new in brackets, that means it is creating a virtual network for you. We have not created a virtual network so far, so hence it is creating a virtual network for me, because in my subscription I do not have a virtual network in East US. So it's going to automatically create a virtual network. But in the subsequent videos, when we talk about virtual networks specifically, I will tell you how to create a virtual network. So it creates a virtual network, a subnet, and is also assigning a public IP to me. Well, I have the option not to do so. So if I do not have a public IP to the virtual machine, I will not be able to access it or DP to it from the internet. Okay, so hence I will have a new public IP assigned to this. Do you want this virtual machine in a security group? A security group is nothing but a firewall. A firewall will have set of rules that will allow or deny incoming or outgoing connections. In this case, I've selected inbound ports to be allowed for RDP. That means this security group or the firewall will have an ACL written or a rule written allowing me to RDP to this virtual machine. Next, do you want to have accelerated networking that will increase the Ethernet speed so that people can do transactions faster at a networking level? Now, because this is a small size machine, it says the VM does not support accelerated networking. Do you want to have virtual machines behind a load balancer? Now, at this time I will say no, because we haven't touched upon the subject of load balancer, so we'll park it for later discussion. Next is management section, where it talks about where you want to store the boot diagnostics or OS guest diagnostics. So just in case this virtual machine ever falls in trouble or a problem, how would you like to troubleshoot that? Well, for troubleshooting purposes, you will need logs. Those logs are boot diagnostics and OS guest diagnostics. Boot diagnostics are storing logs specifically for operating system boot operations, whereas anything in the application or operating system behaviors will be logged in OS guest diagnostics. Now, both of these are going and sitting inside a separate storage account called as payroll diag 555. Now, again, we haven't spoken about storage account yet. When we talk about storage accounts, you will be able to join these dots. But at this time, please remember that both boot diagnostics and OS guest diagnostics are logged inside a storage account called as payroll diag 555. Consider that as just a storage account, just like your hard disk. Identity section, this is whether you want to join it to your Azure Active Directory or not. Just like the way you join your on-premise system to on-premise Active Directories, here by selecting identity, I'm saying that your system, which is this virtual machine, will be joined to Azure Active Directory. Do you want this machine to be automatically shut down? If yes, then you select on and then select the time along with time zone. Do you want someone to get notified before it shuts down? Well, you then go ahead and put the email address here. Okay, let's just select off here. Now, the last option here is, do you want to enable backups on or off? If you select on, then a new service called as Azure Site Recovery or Recovery Services Vault will be enabled. So all the backups will then go inside that vault. This is good for disaster recovery purposes, right? At this time, I'll select off and then click on the next section, which is adding extensions. Extensions are a way to install clients on the virtual machine or antivirus or anything that will supplement the virtual machine's behavior. On the on-premise infrastructure, remember that we had to install several components like a monitoring agent or an antivirus agent, things like that. So those are nothing but extensions. So I can select an extension to install, and there are a lot of default extensions in this menu. So I can check what I want. For example, if I select an antivirus, I'm just looking for Microsoft antivirus in this case. That's the Microsoft anti-malware. I can just say that. Let's click on it and say create, and just leave these options as default and say okay. Now, during the virtual machine provisioning process, this anti-malware will be installed on the machine. So the installation of anti-malware in this case just goes hands-free. I don't have to do anything, right? So that's what extensions mean. The other options, Cloud Init. This is an approach where you can customize Linux virtual machines, but in this case I really do not have a Linux machine, it's a Windows machine, and that's why this informational message says that the selected image does not support Cloud Init, which makes sense because it is only for Linux virtual machines, right? The other option here is VM generation, whether you want a Gen 1 virtual machine or a generation 2 virtual machine. Now, generation 2 virtual machines are considered to be more secure because it's got UEFI based boot architecture. They can support increased memory. Operating system disk size limits are higher. So generation 2 virtual machines are very good at providing enhanced security as well as better speed and performance. Now I'll click on next to add some tags. Tags are only for charging purposes and bill back so that people know who owns this virtual machine or which department does this virtual machine belong to. So in this case, so I can just write like that: name equals web server, owner equals Rob, or application owner equals Steve, and backup team is maybe Mary, and the business unit is payroll. So after creating like tons of virtual machines and different kinds of resources, you can definitely pull up a report and say how many of these virtual machines belong to an owner called Rob, and how many of these resources belong to business unit called payroll, so you can then charge them back. Now I click on next, and this will take a minute to run through the validation just to check if everything is running properly or not. And yeah, validation is passed. Now that's a green signal. Let's just click on create. This will take about 4 to 7 minutes to create a virtual machine. That is the shortest time possible to create a virtual machine, because on premise it used to take months to procure, provision, go through the processes, get the financial approvals to create a virtual machine, or even a physical machine for that matter. But here it's so quick. Now apart from processes, technically creating a virtual machine does not take more than 4 to 7 minutes in this case. You'll be able to RDP once the machine is created. In the next video, I'm going to show you how will you RDP to this virtual machine or remotely connect to this virtual machine. Looks like the virtual machine is completed. The whole virtual machine deployment is created in the resource group, and the resource group name here is payroll. Along with the virtual machine, there were several other deployments here. For example, the storage account was created, the network IP address, which is a public IP, got created, the virtual network got created, and every other thing that you see in this list, one after another. You can find out what exactly happened during its creation by clicking on the operation details button here. Now if I click on resource group called as payroll, I will then be able to see all the resources that exist in this resource group. Let's go ahead and see how we can connect to the virtual machine that we just created. To log on to the virtual machine, I will go ahead and click on virtual machine section right here on the left hand side. Now the list of virtual machines will all be visible in this section, but at this time I have just one virtual machine. The name of the virtual machine is VMweb01, and the public IP that I would like to connect to it is 23.101.139. This is truncated, so let's just expand like that. 227. This is created in a region called East US. Now I want to connect to it. I will launch the RDP section, so all I have to do is hit the Windows key and R button, and you'll get this pop-up. Right here I'm going to type MSTSC, which stands for Microsoft Terminal Service Console. Hit enter, and there you're going to type this IP address, which is 23.101.139.227. Click connect. Now within some time it should pop up for credentials. Now if you get this kind of screen where it is requesting for user ID and password, that means the network configuration is correct. That also means that you have opened the right set of ports on the security groups. The username, remember, it was root admin and not administrator. And the password, don't forget it. And then click on yes. It will take like a couple of seconds to get connected to the virtual machine, load up your profile, and then you are all set to operate on this virtual machine. Traditionally, if you had to create this kind of virtual machine, it will take like several hours to get this established, coordination with the virtualization team communicates with the storage team, and that will take a lot of time just coordinating to create a virtual machine. Right now, here I've got this VM ready. All you got to do is now install the applications and make it production ready. In the next video, let's go ahead and learn how to make it as a web server and how to launch your own web application on this web server. So here's our virtual machine ready to become a web server. To make it as a web server, you need to install the web server component, which we call it as IIS on the Windows machine. If it was Linux, we would have installed probably a Tomcat or Apache on the machine to make it a web server. But this is a Windows machine. So to make it as a web server, you got to click on this little box, which is called as a server manager. And it launches that, and then I need to add certain roles to it, right? And those roles are called as Active Directory roles if you want to make it a domain controller. If you want to make it a DNS server, you will install a DNS role. Want to make it a DHCP server, you will install a DHCP role. But in this case, I want to make it as a web server so that I can host my web application on top of it. So I have to make it as a web server. So I'll click on this, and then as always, you get this wizard. So I'm going to click next. If you're looking at this screen for the first time, I would suggest you to read these little statements here. They're quite informative. Click next. Installation type, do you want it to be a role-based or feature-based? Remote desktop server installation. Now, I want to make this web server a virtual machine, so I'll go for the first one and not a remote desktop one. Click next. Server selection, yes, that's the server, which is going to be a web server. Click next. This is the set of roles that I was talking about. Now I want to make it a web server, so I'll scroll down till the point I see web server IIS. I'll just put a checkbox there, and this pop-up that you get is this set of dependencies which are required for this server to become a web server. Add features, and then click next. Click next again. This is just a set of dependencies, and like I said earlier, if you're doing this for the first time, spend some time reading these things, what exactly it is doing, right? Click next, next again, and finally click on install. Give it some time for this installation to finish, and then it's ready to become a web server. So looks like this machine has become a web server now, because now it says installation succeeded on my server. I click on close, and also close this server manager screen and launch the Internet Explorer browser to verify if it has really become a web server. Just to verify if I can access the website internally within the machine, so it will be a local access. Once that is successful, we can then check if it is accessible from the internet through your mobile phone or any other devices. So I'll just do http://localhost, right? Great. There you go. So you get the default page, which is great. So that means the IIS services are running. The IIS engine is responding to the web request. That's great. I will go ahead and minimize the RDP and see if I can access it from the internet. So go back to my laptop here, launch the browser, and then just type http:// well, localhost will not work. I need to know the public IP address of this machine, which is this. So I'm trying to connect to that machine on the public IP on port number 80, right? HTTP is port number 80. Now it's not going to work. It will just try and try and try forever, but it will not work. Why? Remember that on the security groups, we opened port number 3389 to access RDP. And that's how we could access RDP, but we never opened port number 80, and that's why it's struggling to connect. In the next video, let's go ahead and learn how we can open the security groups on the virtual machine. So this is where we were with the previous video. So we tried to access the web server that we just created, but we failed because the connection timed out. And the problem was that the virtual machine was not listening on port number 80. So now let's go ahead and learn how we can open ports on the virtual machine. Now I'm in the Azure portal. I'll click on the virtual machine here, and then scroll down to the section where it says networking. Don't forget to look at the other options as well here, which talks about the public IP address here, the private IP address, the virtual network in which it is in, etc. And there are other metrics that it's going to display for performance purposes. It tells you how well your virtual machine is behaving. CPU utilization, there is network utilization, the disk IOPS, and the disk operations per second. Now the objective here is to modify the security group, so I'm going to click on the networking section and I will see specific details here. I have opened port number 3389 on this security group, and it is an inbound rule. In the outbound rules, you will have all ports open. You see this NA to the internet. That means everything is allowed out to the internet from the virtual machine because it's an outbound rule. Inbound rules are more restrictive in nature. And that's why I've allowed port number 3389 so you can connect to this virtual machine. Now the objective is to add port number 80, so I'll click on that button and then allow a specific port called port number 80, right? So this will be allowed to any website from any destination on port number 80 on any protocol, whether it's TCP or UDP, and I want to allow this, not deny. And the priority in this case is 310. You can just put any number here, and those rules here will be processed based on this number. So I'll also make it a descriptive name, port number 80, and you can put some description here. Click on add. Now within few seconds it should display port number 80 in this rule set. I have just 4 rules in this rule set in the inbound rule section, and I must be able to see port number 80 as well. There you go. The rule number 310 allows port number 80. So now I'm going to go back to this website and refresh the page. Let's see what happens. There you go. Within a click of a mouse, within a second, I'm able to see the website. In the next video, let's go ahead and learn how do you modify the content of this web page so that you can make it more personal and more customized. Okay, so let's go ahead and make this a customized web server. At this time, I'm logged into the Windows machine that we just created in Microsoft Azure. The objective here is to make this a personalized website. In the last videos, we installed the web service role on this machine, and that's how we were able to get to it. When you install the web service role, you will have certain folders created under C drive and inetpub. Under inetpub, you will have www-root folder. Every time you open the local host, or when somebody tries to access the public IP, they will be connecting to this particular file called as iisstart.html. We can either customize this page or put our own file here and name it as index.html. Open this index.html, and now you are ready to write your HTML content inside this particular file. Now you can write simple text like this. This is a sample web page. Or if you know HTML or how to write HTML, you can definitely write the HTML content right here. I will save this page because I don't want to complicate things by writing HTML code, but if you know HTML, please feel free to do so. I will close it. And if you notice, this page does not appear to be an HTML. This is still a notepad. You see this? There's a difference here. It's a text document, and this is an HTML document. So although the extension here appears to be .html, it is not an HTML document. That is because the extensions are hidden. What does that mean? Let's go ahead and see this. If I click on view and then click on this file name extensions, check this. You will notice that index.html is not index.html. Instead, it is index.html.txt. So I will right click and rename this and remove the last 4 characters. And that will make it an HTML document. Now it has got its own icon as well. Let's go ahead and refresh this page in the background. I'll hit F5 on the keyboard. And as you see, the local host is now pointing it to the new file that we just created. What will happen if I do the same thing on my local laptop? So I will minimize this server and then go back to this little screen and then refresh the page. Now instead of going to the default IIS page, it should take me to the new file that I got created. There you go. Just by refreshing it, it is taking me to the new file. So every time you create a website, by default, it points it to the index.html. So even if I do index.html like this, it will be taking me to the same file. So in this video series on virtual machines, you learned about how do you create a virtual machine in Azure, how do you make it a web server, and how do you access the web server from the internet and from the intranet. Then we learned how to customize the web page.
So far, we learned about creating and managing a virtual machine using the graphical user interface. But at times, you may have to manage and do the same activities using PowerShell if you have to do things repeatedly. It's always important to have a knowledge of PowerShell, so let's also see how you can do the exact set of activities using PowerShell. In this demonstration, we'll create a virtual machine with Windows 2016 Data Center Edition using PowerShell. So I've got the PowerShell open, and first thing that I will do is connect to my Azure account. For that, I need to type in my user ID and password and get myself authenticated to Azure. Okay, now that we are authenticated, now there are several entities for a virtual machine: an operating system, an image, hard disk, network card, ports. All of these are entities for a virtual machine, and you have to write a commandlet for every entity. So first thing first, we have to start with credentials, because when a virtual machine is created, it will need an administrator, user ID and password. It will need a disk, image, etc. So we'll start with the credentials. So let's store the credentials of the virtual machine inside a variable called $cred and use get-credentials to call it. So when I hit enter, it will prompt me to type in my credentials. So I'll type like that. Alright, so those credentials that I just punched in is stored inside this variable called $cred. A virtual machine has certain sizes and specifications, like the CPU and the memory is what I'm referring to. So let's go ahead and use a variable called as $VM to put that information, specifically the VM sizes. This is done with a commandlet called AZ-vmconfig. The name of the virtual machine will be my VM, and the VM size is standard_D1. When I hit enter, these variables are stored inside a variable called $VM. Now, if I call $VM, what am I going to get? It tells me that it is a hardware profile and the VM size is specified inside $VM. The next thing that you will need for the virtual machine is an operating system, which I can pull up using the following command. So what you have is an operating system which you're setting with the commandlet set-azvm operating system, storing these values inside the attribute called $VM, and you need a Windows machine. The name of the virtual machine is my VM. The credentials that are used are already specified in $cred variable here, and then you would like to have the provisioning VM agent automatically updated every time Microsoft updates in the backend. So let's hit enter and store all of that data inside $VM. Now if I call $VM this time, what do I have? Well, I have hardware profile and the OS profile as well, including the variables like these. So $VM is a variable that has a lot of information now. For example, name, hardware profile, and the operating system profile as well. So we are building the profile slowly for this virtual machine. And once we are done building the profile, we will call the virtual machine attribute to create a virtual machine with these profile attributes. What do we need next? An operating system is picked up from an image. So we need to tell the virtual machine where it needs to pick up the image from. So this is where we are telling that the source image will be a Windows server. It will be a 2016 data center and pick up the latest image from the Microsoft repository. So if I hit enter, these values are further stored inside the attribute called $VM. Now if I call $VM, we would have additional profile for this. So we got three attributes: the name, hardware profile, OS profile, plus the storage profile now, which is referring to an image. What do we need next? We also need to specify the hard disk size. Is it an SSD or it is picked up from an image? Do you need a read-write image or just write-only disk? Well, these are certain attributes that are specified with the commandlet called set-azvmosdisk, storing them in a variable called $VM. The size of the disk is 128. Let's hit enter and store it again in $VM. Now if I call $VM, I have image reference and the OS disk at this time. Earlier we had just the image reference. Now what's left is the network card. We need a network card attribute as well. I have already created a network card in my Azure portal. So if I go here, my VNet, under that there is a virtual network. And this virtual network has certain properties. And one of the properties is the resource ID. This network card is not attached to any device. I would like to attach this to the new virtual machine. I would need this resource ID, so I'll copy this attribute, go back to my PowerShell, and start using that particular attribute. So at this point in $VM attribute, I have just the name, hardware profile, OS profile, and storage profile. I want to add the network profile as well. The network profile is added with the following command, which is add-azure VM network interface connecting to the same VM, and the ID will be what we just copied from the Azure portal. This section, the resource ID, is nothing but the ID. So I'll go back to this and hit enter. Now if I go back to $VM, I have the network profile as well. Apart from hardware profile, OS profile, storage, now you got the network profile as well. So what do we do next? We have to now call this $VM attribute to create a virtual machine for us. So the command will be new-azure VM, new-azure VM or AZVM, and I want to create it in a resource group called prod_IT. The location will be in East US, and finally the VM will be $VM. So all the properties of the $VM would be called, which are all specified right ahead of time. So we'll be calling $VM using the commandlet called new-azure VM. Let's hit enter. Okay, we've got a warning, that's fine. Let's just wait for a minute to get the VM provisioned. Looks like the VM is ready. We didn't get any messages or any error messages, so no news is good news. Let's go back to the portal and see if the VM is actually created. So here's the portal, refresh it, and let's see, looks like our VM, my VM, is ready. There's also a public IP associated with that. But let's try to get that information from the PowerShell. So I'll launch PowerShell again and use the command called get-azvm to get the VM statistics. The VM that we have in hand is my VM. So what are the attributes that you can pull for Azure Virtual Machine? Now if I say get-azvm and then pipe to get member, it will tell me all the properties that I can pull for the virtual machine. For example, certain properties are network profile, OS profile, the name of the virtual machine, location, etc. These are not the actual properties of the virtual machine, but the properties that this commandlet can pull for you. For example, if you're looking for tags, I can just say get-azvm and store this in a variable called as my VM, right? Oops. Okay, and then hit enter. That means my VM has all of these attributes. Then I can say $VM, $myVM dot, and then toggle to each of the properties that you see on the top here, right? So one of the properties is name, like location is also an attribute. Location is used East US. You can say $VM.name is my VM. So similarly, you can toggle to other attributes depending on what you're looking for. You may want to pick and choose a particular attribute. Let's say I want to see the network profile. That is a network profile. That is my network card, right? So let's say you want to get the IP address of this virtual machine using um, PowerShell. How would you do that? So the commandlet will then be get-az public IP address, and you want to get it for a particular virtual machine or network interface name. What is the network interface for this? It's my NIC, my VM NIC, right? Let's hit enter. So the parameter set cannot be resolved using the specified name parameters. So I'll try again with hyphen resource group name, and my resource group is prod underscore IT, and hit enter. Let's see what we get. All right, so we have a public IP address right here. Looks like there is a network card with the name my public IP, and its IP address is 104.41.145.114. Now if you would like to connect to it, you'll just see mstsc/v colon and then the IP address, which is this. Now if you have 3389 port open, it will just RDP and connect directly. There you go. So it asks for the user ID, password, and then you connect to it. So in this video, we learned how you can create a virtual machine using PowerShell, how you can pass the attributes to the PowerShell in the variables called $VM in this case. And then finally, we also learned how you can get the attributes or properties of the virtual machine using PowerShell. Creating a Linux machine is no different from creating a Windows machine, but you use a different tool to connect to the Linux machine. You do not use the same RDP or MSTSC console because Linux does not listen on port number 3389. When you use RDP to connect, or when you use MSTSC like a Microsoft Terminal Services console to connect to a Windows machine, you're transacting on port number 3389 TCP. But when you connect to a Linux machine, you are doing an SSH on port number 22 TCP. So SSH is an encrypted connection protocol that will allow you to securely sign in over unsecured connections. SSH is a default protocol for Linux virtual machines hosted in Azure. Although SSH itself provides an encrypted connection, using passwords with SSH connection still leaves the VM vulnerable to brute force attacks. A more secure and preferred method of connecting to a VM using SSH is by using a public-private key pairs, also known as SSH keys. In this video, we'll learn how do you create a Linux machine, which I already said that it's no different from creating a Windows-based machines. And we'll then learn how do you create keys, a public and a private key pair, to connect to those Linux instances. A public key is placed on your Linux VM and a private key remains with you on your local system. You always need to protect your private key and do not share it. Let's get started. We'll learn how to create a Linux machine, then create a public and a private key pair to connect to the Linux machine. I'm currently logged into the Azure portal. In the virtual machine section, I will click on the add button to quickly create a Linux machine. Fill in these values. I'll select the resource group called Lab IT, call this virtual machine as a Linux web server or something. Okay, and then host it in East US. And then I will select image of Linux kind. It could be Ubuntu, Red Hat, SUSE, or CentOS. We do not need so much of computing power to this VM, so I'll select something lesser. Probably 2 gigs of memory should be fine for our lab. I have two options to connect to my instance. One is a password and other is an SSH public key. If you select password, it is again the same as Windows, where you type the username, password, and confirm the password. But in case of SSH public key, you need to create a public and a private key pair. And that is done using tools. There are several tools out there which will let you create public and a private key pair. I usually use, in fact, most of the Linux administrators use a putty gen, which you can download from the internet. Just type putty gen on the search browser and you will be able to download that quickly. First step that you have to do is click on generate. Now this will open up this box here, and this box will move from left to right only if you move the mouse continuously on this empty blank space, right? So move it for a couple of times. You can also use keystrokes on the keyboard. Once that is ready, this is your public key. Okay, so what you have to do is copy this, copy the whole thing and paste it here, and then make sure that you type a username. Alright, now this will be validated. Make sure that you save a private key because this is a public key which you are embedding inside your Linux machine. Then you need to save a private key. Let's click on save a private key. You have the option to protect it with a password, yes or no. Usually administrators will save it with a password. I'll save it in a folder and give it a name. The name doesn't matter at all. Okay, now that is saved, you can move on. Inbound ports need to have at least port number 22 allowed because Linux listens on port number 22. Unlike Windows, in Windows we selected RDP 3389. In Linux it is SSH 22. Next, because it's a test environment, I can just go for a standard HDD. And since I've explained these particular fields in the previous videos when creating a Windows machine, I'll not go over them again in order to save time. Click next, advanced. In fact, these values are no different from what we had during the VM creation for Windows. Now click on create and then wait for this to complete. I'll pause the video for a minute to get the VM created successfully. Looks like the VM deployment is complete, so let's go to the virtual machine section here and then click on it to get the public IP address. That's my public IP address. I just copied it. It's in my clipboard. Now we do not need this putty gen anymore, right? We need putty. So I will launch putty and copy and paste that public IP. Now I also need to have an SSH key embedded inside this auth. The Linux machine knows about my public key. I need to show the private key to the virtual machine so that there will be a handshake between public and a private key, and hence the term public private key pair. Now if the ports are open, right, if there is a network communication built between the network that you have and between the virtual machine, then you get a pop-up like this. Now everything is alright. Login with root admin, and then I don't need to type the password because now the handshake between public and private key pair happens. It's all ready now. So this virtual machine is ready to be hosted in your production. We are connected. Now you can show your Linux skills to make it a web server or something. So let's quickly make it a web server. Now, just like the way we installed IIS on the Windows machine, you can install Apache on it by just running this command, say sudo yum install and the httpd daemon. Give it a minute and within a short time it should install and pick up all the libraries from the internet. Install the http daemon on your machine. Alright, so yes. Okay, let's start the service for the Linux machine, which will be sudo service httpd start. Done, service is started. Now I'll go to the browser and just copy and paste the public IP here. Let's see what happens. Now it's not gonna work. It's still waiting and waiting, and it will time out because we haven't opened port number 80 on the security groups. So I'll go back here, click on networking, and see, if you look at this, just port number 22 is open, and that's why we could successfully connect to the Linux instance. We haven't opened port number 80. Let's open it. Under inbound rules, I just want port number 80 here, which is responsible for HTTP communications. Yeah, and that's all. Just click on add. Give it a second and It should finish that. Okay, looks like port number 80 is open now. I'll go back to this web page and refresh it. It's still waiting. Let's see. So I just refreshed it a couple of times and now I'm able to see the default page of the Apache web server. So that's how quickly it is to create a Linux machine and also make it a web server. Now you can start putting your own files, your own custom web page inside the Linux machine to make it a custom web page. In this video, we learned how do you create a Linux machine and then use a public and a private key pair to connect to that Linux machine. So instead of using passwords, you will use a public private key pair. We also made that Linux machine as a web server, opened port number 80 on the network security groups, and then we were able to access the Linux machine using the browser using http://public IP. As an Azure administrator, you must be prepared for planned and unplanned failures. There are three scenarios that can lead your virtual machine in Azure being impacted. Number one is unplanned hardware maintenance. Second would then be unexpected downtime. The third one is planned maintenance. Let's talk about each one of them one by one. An unplanned hardware maintenance event occurs when an Azure platform predicts that the hardware or any platform component associated to a physical machine is about to fail. When the platform predicts a failure, it will issue an unplanned hardware maintenance event. Azure uses live migration technology to migrate the virtual machines from the failing hardware to a healthy physical machine. Live migration is a virtual machine preserving operation that only pauses the virtual machine for a short time. But you will notice certain performance issues after or before the event. Unexpected downtime. Unexpected downtime is when the hardware or the physical infrastructure for the virtual machine fails unexpectedly. This can include local network failures, local disk failures, or other rack level failures. When this is detected, the Azure platform automatically migrates your virtual machine to a healthy physical machine in the same data center. And this is also called as auto healing. During the healing procedure, virtual machines experience downtime and in some cases also lose a temporary drive. What is a planned maintenance? Planned maintenance events are periodic updates made by Microsoft to the underlying Azure platform, and this is done to improve overall reliability, performance, and security of the platform infrastructure that your virtual machines run on. Most of these updates are performed without any impact to your virtual machines or other cloud services. Microsoft does not automatically update your virtual machine's operating system or software. You have complete control and responsibility for that. But the underlying software, the host, and the hardware are periodically patched to ensure reliability and high performance at all times. For redundancy purposes, we usually keep two or more systems in the design. This makes sure that even if one server goes down, there is another one handling business requests. We as admins also need to make sure that the hardware maintenance or patching of these machines do not happen at the same time. Microsoft Azure Availability Set is just that. It means that virtual machines that are kept in the same availability set will not be subject to a single point of failure, and not all of them will be upgraded at the same time. Virtual machines placed in an availability set should perform an identical set of functionalities and have the same software installed. Azure ensures that the virtual machine you place within an availability set will run across multiple physical servers, compute racks, storage units, and network switches. If a hardware or Azure software fails, then only a subset of your virtual machines are impacted, and your overall application stays up and continues to be available to your customers. When you want to build reliable cloud solutions, availability sets is an essential capability. There are a few things that you need to note when you're creating an availability set. For redundancy, configure multiple virtual machines in an availability set. Configure each application tier into separate availability sets. Combine a load balancer with availability sets. And always use managed disks with virtual machines. Another important concept of availability set is fault domain and update domain. When you put your virtual machines into an availability set, Azure guarantees to spread them across fault domains and update domains. A fault domain is essentially a rack of servers. It consumes subsystems like network, power, cooling, etc. So two virtual machines in the same availability set means Azure will provision them in two different racks so that, let's say, if the network or power failed, only one rack would be affected. So a fault domain defines a group of virtual machines that will share a common set of hardware switches that share a single point of failure. For example, that will be a server rack serviced by a set of power or networking switches. Virtual machines in an availability set are placed in at least two fault domains. Now this mitigates against the effects of hardware failures, network outages, power interruptions, or software updates. Let's talk about update domain. Sometimes you need to update your application, or Microsoft needs to update the host on which your virtual machine is running. Now with IaaS virtual machines, Microsoft does not update your virtual machines. You have complete control and responsibility over that. But let's say if a serious security vulnerability is identified and a patch is created, it is in Microsoft's interest to get that applied to the host underneath your VM as soon as possible. So how is that done without taking your service offline? Update domain is the answer. It is similar to fault domain methods, only this time, instead of accidental failure, this is a purposeful move. This is a purposeful move to take down one of your servers. So to make sure your service does not go offline because of an update, it will walk through your update domains one after another. So what is an update domain? An update domain allows Azure to perform incremental updates across your deployments. Each update domain contains a set of virtual machines and they are associated physical hardware which can be updated and rebooted at the same time. During a planned maintenance, only one update domain is rebooted at a time, but by default, there are 5 update domains. But you can configure up to 20 update domains if you like.
Creating and maintaining virtual machines can be a lot of work, and most of it is repetitive. And this requires same steps each time. After provisioning the virtual machine, sometimes you have to install other components like monitoring agents, configuration management agents, backup applications, antiviruses, etc. Installing and configuring these little applications can take time as well. VM extensions is a method to inject these applications during the VM provisioning so that you do not have to configure them repeatedly in every virtual machine in your infrastructure manually. Azure has lots of virtual machine extensions in its library. However, if you would like to customize installation of your app, then you can write your own script and upload it from custom script extensions. Your script can include PowerShell commands that you want to execute on the virtual machine. Once the file is uploaded, it will execute immediately. There are certain things to consider. When you're writing the script, make sure that you consider these points before you deploy it using custom script extension. Timeout. Custom script extensions have 90 minutes to run. If your deployment exceeds this time, it is marked as timed out. So keep this in mind when designing your script. And of course, your virtual machine must be running to perform these tasks. They cannot be in shutdown mode. Always consider dependencies. So if your extension requires networking or storage access, make sure that the content is available. Be sure to account for any errors that might occur when the script is running. For example, running out of disk space or security and access restrictions. What will the script do if there is an error like that? Consider handling sensitive data. Your custom script extension may need sensitive information such as credentials, storage account names, and storage account access keys. How will you protect and encrypt this information? Let's go ahead and look at the extensions feature in the Azure portal. I've created the virtual machine right here and its name is new VM. The extension option is available under settings. So if you click on settings, you will then see the add button. We can then click on this add button to see all the extensions that Azure has as on today. So if you are using Acronis Backup to back up your infrastructure in Azure, you can just click on it and then install. Microsoft Anti-Malware can be installed, Chef extensions, and there are a lot of these extensions that are pre-built for us, so we do not have to write a script to install these agents. But let's say the application that you want to install is not available in this list. Then you might want to go for a custom script extension. So if you would like to go for, let's say, Microsoft Anti-Malware, you can just click on it and then create and then specify the parameters of the antivirus. You can of course modify this later, but I'll click on OK. So what this means is that the virtual machine will now have this Microsoft Anti-Malware installed in some time. I can add multiple extensions at the same time. Let's add a custom script extension. Now, for me to add a custom script extension, I should have created a PowerShell script beforehand. Then I click on the Browse button and then browse to that PS1 file. Additionally, you can pass arguments or syntaxes to that PowerShell file. Now, while my Microsoft Anti-Malware is getting installed on the virtual machine, I would like to go ahead and create a script so that I can then pass it as an extension to this virtual machine. I'll click on Add and then click on Custom Script Extension, Create, to add a PowerShell. Now, let's go ahead and write a small PowerShell script. I will launch PowerShell ISC here and then write a small script called install hyphen Windows feature hyphen name, and I want to install a component called web server on that Windows machine. Let's start something small. So let's just start by installing this Windows component called web server. So this should go ahead and install IIS on my Windows based machine. I'll save it as a PS1 on my computer. So I'm saving it as install web service.ps1 inside the script extensions folder. Now it is saved. Now you can go back to the custom script extension and then click on this browse button to browse to my file. So I'm here in the script extensions pointing it to install web service.ps1. Upload is complete and then I just click on OK. I'll wait for the deployment to complete. Parallelly, I can just go ahead and click on Overview and connect to this virtual machine quickly so we can then log in and check if the installation has happened. Okay, so it looks like my virtual machine is ready. I will connect to the PowerShell here and see if I have, oops, I'll just type get hyphen Windows feature to see the IIS component if it is installed on this machine or not. So it looks like there is a lot of data that popped up. So I will just say get hyphen Windows feature, narrowing down to web server. Okay, so it looks like it is installed. At this point, we just noticed that the IIS is installed on the machine, and this was installed through custom script extensions. Let's also go to the add remove programs to see if the antivirus is installed, which is Microsoft Anti-Malware should be installed through Yeah, so this is System Center Endpoint Protection, which is nothing but Microsoft way of representing its own antivirus. So System Center Endpoint Protection, anti-malware is installed on the machine. Now, if you go back to the Azure interface under extensions, we'll see that IaaS anti-malware provisioning has succeeded, and also custom script extension is right there, but the status is unavailable. So we should just wait for some time and then we'll see the status as provisioning succeeded. In this demonstration, we learned that applications and agents can be installed on the virtual machines in Azure through custom script extensions. These custom script extensions can be either picked up from the marketplace or you can write your own custom PowerShell script.